Hi, in this video, I will be showing you problem number 5 of chapter 13, section 4. Find the velocity, acceleration, and speed of a particle with a given position function. Sketch the path of the particle and draw the velocity and acceleration vectors for the specified value of t. Vector r of t equal to 3 cosine of t I plus 2 sine of t j, where t equal to pi by 3. So how do we find the velocity, speed, and acceleration of a particle that moves along a space curve? If r of t is the position vector of the particle on the space curve, then the velocity vector v of t is the first derivative of r of t. And the speed is absolute value of r of t. And then acceleration is the derivative of velocity, that is second derivative of the position function or double prime t. The speed is absolute value of the velocity vector. Now t is given to be pi by 3. Then now we'll substitute that pi by 3 in order to get r of t. R of t is given to be 3 cosine of t I plus 2 sine of t j, where t is replaced by pi by 3. So if we substitute, we get r of pi by 3 is 3 cosine of pi by 3 I plus 2 sine of pi by 3 j, which were reduced to 3 times 1 half I plus 2 times root 3 over 2 j. The 2 and 2 cancel out. So you get 3 halves I plus root 3 j, which is the position vector at t equal to pi by 3. Now also we have to get the velocity and the acceleration. Velocity is given by the derivative of r of t. So we will differentiate this function, 3 cosine of t I plus 2 sine of t j, which is negative 3 sine t I plus 2 cosine of t j. Now we'll find out the velocity at pi by 3. So substitute pi by 3 into this t, which will be negative 3 root 3 over 2 I plus 2 times 1 half j. So v of t is equal to negative 3 root 3 over 2 I plus 1 j. So this is the velocity at pi by 3. In fact, at t equal to pi by 3. The next part is the acceleration. So v of t is negative 3 sine t I plus 2 cosine of t j. So if we differentiate this, we are going to get the acceleration. So a of t equal to negative 3 cosine of t I minus 2 sine of t j. As we did in the earlier cases, we have to determine this acceleration. These are all vectors, so you need to put an arrow on top. And we need to get this a of t at t equal to pi by 3. So a of pi by 3 would be equal to negative 3 times 1 half I minus 2 times root 3 over 2 j. Simplifying, we get negative 3 halves I minus root 3 j. So this is acceleration at pi by 3, at t equal to pi by 3. The last part is only the speed, which is the magnitude of the velocity vector. the speed is magnitude of the velocity vector, which is equal to square root of x component of velocity square plus y component of velocity square. So it's negative 3 sine of t the whole square plus 2 cosine of t the whole square. This will be 9 sine square t plus 4 cosine square t. In order to make this look better, we can use the Pythagorean identity, which is sine square t plus cosine square t equal to 1. So we'll break the 9 sine square as 5 sine square plus 4 sine square. Then plus we'll add this 4 cosine square as well. So we'll keep this 4 cosine square as is. So here what we are doing is, we are writing sine square as 5 sine square t plus 4 cosine sine square t. So which is 5 sine square t within the radical plus 4 times sine square t plus cosine square t, which will be equal to 1 by Pythagorean identity. So which becomes square root of 5 sine square t plus 4. That is the speed of the particle. Hence, as x equal to 3 cosine t and y equal to 2 sine t, which we find from r of t, by writing it parametric form, if you isolate cosine t and sine t from here, and then also use the Pythagorean identity, we will get the trace of the particle, the path of the particle. So cosine t is x over 3 and sine t is y over 2. As sine square t plus cosine square t equal to 1 from Pythagorean identity, if you square this and add, we get the path of the particle, which turns out to be x square over 9 plus y square over 4 equal to 1, which is an ellipse, which is the path of the path of the particle. We are also asked to sketch this graph. So we are going to, if you look at that ellipse, it's x square over 9. So on the x-axis, it is 3. On the y below, y square over 4. So on the y-axis, it will be 2. So on the y, it is 2. On the x, it is 3. Then complete the ellipse. Here we are going to mark the point R at pi by 3, which we found out to be equal to 3 over 2 root of 3. So we will plot that point, and also we have 3, 0, which are the vertices, at the negative 3, 0 are the vertices. And the point is 3 over 2, root 3, which is that point at pi by 3. Then we have to, at this point, starting from this point, we have to do the tangent vector, the velocity vector and the acceleration vector, which are parallel to the position vectors. So at that 3 over 2 root 3, the velocity vector is actually that we found out to be negative 3 root 3 over 2 I plus j. So if you look at that v of t, it is negative 3 root 3 over 2 I plus j. This shows that we have the x component negative and y component positive. So it's going to be directed towards the second quadrant, that is v of pi. That's why the arrow is shown like that for v of pi by 3. Then same way the acceleration is going to be pointed towards the third quadrant. The reason being acceleration pi by 3 that we proved is negative 3 halves I minus root 3j. So here the x component and the y component both are negative. So it is pointing towards the third quadrant. Hope this video helps.